Today's lesson is lesson 3 on adding and subtracting rational expressions. So far in this unit, we've learned about factoring, we've learned about non-permissible values, we've looked at simplifying rational expressions, and we've looked at multiplying and dividing rational expressions. So now it's time to add and subtract. So a bit of prerequisite skills that you need to be able to do for this unit is simplifying the following, so collecting our like terms. So in the first example, I see that we have 2x plus 4 plus 3x minus 7. So those brackets are there, but they really don't indicate anything because they're not right beside each other. If they're right beside each other, it would mean multiplication. But here we are just adding our like terms. So remember, a like term is something that has the same base and the same exponent. So 2x and 3x are like terms. And positive 4 and negative 7 are also, or subtract 7 are also like terms. So 2x plus 3x, that is going to be 5x. And positive 4 subtract 7 is going to be subtract 3. So our simplified version of this is 5x minus 3. Okay, great. So the next one we have like terms again. My x squareds are going to be like terms, x squared and 2x squared. My negative 4x and my negative 3x are like terms. And then my positive 8 and negative 9 are going to be like terms. So I'm going ahead and adding x squared plus 2x squared, which remember you can put an invisible 1 there to make it 1x plus 2x, which is 3x squared. The x squared part does not change. And then I can change negative 4x minus 3x to be negative 7x. And lastly, positive 8 minus 9. Use your number line or your calculator. Will give you negative 1. So simplified version is 3x squared minus 7x minus 1. For the next question, we have a subtraction sign. So the subtraction sign definitely means you have to change things. Instead of adding, we're subtracting, but we're not just subtracting the 7x squared, we're also going to be subtracting the 9x and the negative 5. So a little trick here that I use is add the opposite. So my 4x squared at the beginning plus 6x minus 3, that's not going to change. It's not affected at all by the subtraction sign. But then I'm going to add, so change my subtraction to addition, the opposite. So this is going to become minus 7x squared. Positive 9x is going to become minus 9x. So it's adding the opposite sign. And then negative or subtract 5 is going to become plus 5. Everything changes sign in order to subtract it. Now I go ahead and collect my like terms. 4x squared minus 7x squared is negative 3x squared. 6x and negative 9x is negative 3x, and negative 3 and positive 5 gives me plus. We're left with a trinomial at the end, negative 3x squared minus 3x plus 2. So you're going to be able to collect like terms when we're adding and subtracting rational expressions. So here are the steps for adding and subtracting rational expressions. First, we want to factor the denominators if possible. So some of them, especially if they have monomials on the bottom, they can't be factored, so we can skip that step. You can see there for the first example and the second example on this page that we're not going to be able to factor the denominators. Next, determine the common denominator. And then 3, convert the fractions by multiplying the numerator and the denominator by the same thing. And then lastly, add or subtract numerators and write the result over the common denominator. So just one quick refresher on how we would add fractions. If I had 1 over 2 plus 1 over 4, I cannot add straight across. I need to find a common denominator. So my common denominator in this case would be 2. So I would multiply my first fraction by 2 over 2. And that would give me 2 over 4. We notice that 1/2 is equivalent to 2 over 4. So 2 over 4 plus 1 over 4. Now that I have my denominators the same, I add my numerators and I leave the denominator the same. So it becomes 3 over 4. So I'm going to take that same principle and apply it to rational expressions. So if the denominator is the same, I can keep the denominator and add or subtract the numerators. So for my first example, I notice it already has a common denominator of x squared. That's perfect. That reduces my workload. So I can add and subtract the numerators, 3 minus 5 plus 11, but bring it to one common base. Because they're all the same, I can bring them to one fraction, and it becomes 3 minus 5 plus 11 divided by x squared. I then take 3 minus 5 plus 11. 3 minus 5 plus 11 is 9. So my final answer is going to be 9 over x squared. So the basic principle that we have to remember here is get the denominator to be the same, and then we can add the numerators while leaving the denominator the same. So that's my final answer. And then don't forget to state your non-permissible values. In this case, we just have a monomial on the bottom of the fraction, so it's x cannot equal 0. Okay, let's try the next one here. 3x minus 2 over 4 plus x minus 4 over 3. So I look at that and I see the denominators are different. So I cannot just go ahead and add them right away. Instead, I have to think about making a common denominator. So a rule to make the common denominator is list your multiples of each number. So 4, 8, 12, 16, that's my multiples of 4. And then list your multiples of 3. So 3, 6, 9, 12. And you're looking for the lowest number in both of those lists. So the lowest number in my list of multiples of 4 and 3 is 12, which means my lowest common denominator is going to be 12. So then you ask yourself, what do I need to multiply each side by 12, or each fraction by to get 12? Sorry, not side. So I'm going to multiply my first fraction by 3 to get 12, right? If I multiply 3 by 4, I get 12, but if I do it to the bottom, I have to do it to the top as well. The second fraction, I have to multiply by 4 to get a 12 on the bottom. I'm going to multiply my first fraction by 3 over 3. That doesn't change the fraction because 3 over 3 is just like multiplying by 1. 3 divided by 3 is 1. And the second fraction, same thing, 4 divided by 4, that's 1. So now I can go ahead and multiply those through, making sure that I use distributive property like we learned in the introduction lesson. So I get 3 times 3x is 9x. 3 times negative 2 is negative 6 over top of 12 for my first fraction. And for my second fraction, we're distributing backwards here. So I'm going to multiply x by 4 and 4 by negative 4. You want to write the fraction on the other side. Go ahead. So I have 4x minus 4 times 4, which is 16, all divided by 3 times 4, which is 12. So now we have a common denominator. That means that I can add or subtract my numerators and leave the bottom the same. So I'm going to get, let me code it here. 9x minus 6 plus 4x minus 16 all over top of my common denominator of 12. So remember, I don't add 4 plus 12. The 12 just stays the same. Now I can go ahead and collect my like terms. 9x plus 4x, that's 13x. And negative 6 minus 16, I believe that is negative 22, all over top of 12. So as one final check, make sure that you cannot factor anything or simplify anything at the end. So I see here 13 is a prime number, so I won't be able to simplify this any further. So then I can just state my non-permissible values. Remember, for my non-permissible values, I need to go back to the original question. Oh, look at that. There are no variables in the denominator of my original question, so I don't have any non-permissible values. For the next example, I have x minus 2 over x squared minus 3x. So you need to be thinking to yourself, what am I going to get my lowest common denominator to be? There's no factoring involved yet. So my lowest common denominator is going to be 3x squared. How did I get that? Basically, I had to combine my denominators because they're monomials and say, what can I get them to equal that will be the same by multiplying? So I can multiply my first fraction by 3 over 3, and that will get me 3x squared on the bottom. And I can multiply my second fraction by x over x. So now we're going to be multiplying by variables to get a 3x squared on the bottom. So let's see what that gives us. On the top, distributing my 3, that gives us 3x minus 2 over top of 3x squared. And subtract 4 times x, which is 4x, over top of 3x. Now I see that's perfect. My denominators are the same. I am going to go ahead and subtract 3x minus 2 minus 4x over top of 3x. Okay, go ahead, collect your like terms. Move up here. 3x minus 4x is negative x minus 2 all over top of 3x. So check, make sure we can't simplify any further. No factoring can be done, so then we just say x cannot equal 0 as our non-permissible values, as we have monomials on the bottom of my fraction. Okay, so that is my final answer. Go ahead and try the your turns. Pause the video. Here are the solutions for the your turns. I want to point out two different things. First thing I want to point out is this addition sign here. So that's the most common mistake I get, is people putting minus 3x there. So the reason it is addition is because we want to add the opposite. I change this to addition, I need to change this to negative 6x squared and this to plus 3x. That's why it's plus 3x. The other thing that I wanted to mention is how tempting it is to cross off this 6xy with this 6xy. Well, remember what we talked about, that monomials can only be crossed off with monomials, and other than that, we cannot cross it off. This top 6xy is connected to a whole bunch of other things if we wanted to put brackets around it. So unless I have that identical thing on the bottom, I cannot cross it out. So it's going to stay like, just fix that. So moving along, after you're finished checking your answers, let's do a couple more challenging ones. So these ones now are usually going to have binomials on the bottom of the bar. So on the first one, I see that they already have a common denominator of x minus 3. That makes my life a lot easier. If that's the case, I can just add or subtract the tops and be done with it. So on the top, I'm going to have 2x squared minus 13x. And then, subtraction sign. So I'm going to add the opposite. I'm going to change this to positive, which change this, the first one to negative 3x, and then this one to positive 10x. So it's going to be minus 3x squared plus 10x all over top of x minus 3. So the denominator is already x minus 3. Perfect. Now I can collect like terms. 2x squared minus 3x is going to give me negative 1x squared, or negative x squared. And negative 13x plus 10 gives me negative 3. Okay, almost finished. I noticed that the top can be factored, so I am going to factor out a negative x, and I'll be left behind with x plus 3. Oh, so close to being able to cancel off the bottom. Those need to be identical in order to cancel them out. So my final answer is negative x times x plus 3 over top of x minus 3. And now I'll state my non-permissible value is x cannot equal positive. So the next one, I now have two binomials. I have an x plus 4 on the bottom of my first fraction and an x plus 3 on the bottom of my second fraction. So if that's the case, it's actually not as hard as it looks. We're just going to make the lowest common denominator x plus 4 multiplied by x plus 3. So essentially, I'm going to take the first fraction and multiply it by the denominator of my other fraction. So I'm going to multiply this one by x plus 3, and then whatever I do to the top, I must do to the bottom. So I multiply top and bottom by x plus 3. And the other one here, I'm going to multiply by x plus 4. So that will give a common denominator of x plus 3 times x plus 4. And we're actually going to leave it like that instead of expanding. So I now have 4 multiplied by x, which is 4x. I have 4 multiplied by 3, which is 12, over top of x plus 3 over x plus 4. Okay, the second fraction, subtract 5x, x times 5, and 4 times 5, which is 20. All over top of x plus 3 over. Okay, I see that the denominators are the same, so I can add or subtract the bottom. I get 4x plus 12. Then I see it's that same subtraction sign, so I'm going to add the opposite, negative 5x minus 20. Yellow, I have negative 5x minus 20. Okay, all over top of my same common denominator, x plus 3 over top of x plus 4. My last step will just be to collect the like terms and see if I can factor them. So 4x minus 5x gives me negative x, and 12 minus 20 gives me negative 8 on the top. And then on the bottom, I have x plus 3 over top of x plus 4. Great, that's my final answer. No more factoring can be done. So now I state my non-permissible values. X cannot equal -3 or -4. Okay, 2 more examples before we're done the lesson. So now I not only have a binomial on the denominator of my fraction, I also have a monomial on the bottom of my fraction. So if this is the case, my lowest common denominator, my LCD, is going to be b multiplied by b plus 1. And we're going to leave it like that. We're not going to expand or anything like that. So the first fraction needs to be multiplied by b. You're starting to see a bit of a pattern. We're always going to multiply by the opposite denominator. And this one here needs to be multiplied by b plus 1. So I have here b times 2b is 2b squared over top of b times b plus 1. And here we have 5b plus 5 all over top of b times b plus 1. So my common denominator is there. Now I can go ahead and combine the numerators. Oh, there's that subtraction sign. I'm going to change it to addition and change anything on the top of my fraction to have the opposite. So minus 5b. And you can change it to plus minus 5b if you would like. Minus 5 all over top of b times b. Lovely. There are no like terms there, so that is my final answer. State my non-permissible values. B cannot equal 0 or -1. Okay, last one. We actually haven't even had to do this step yet, but if you recall, the first step was to factor the denominators if possible. Haven't had to do that yet. But I see here x squared minus 16 on the denominator. I have to factor that so that I can complete this question. So that is a difference of squares. It's going to be x minus 4 times x plus 4. And the second fraction is going to stay the same. Now I see that one fraction has two binomials, x minus 4 and x plus 4 on the bottom, and the second fraction only has x plus 4. So I need to go ahead and multiply by x minus 4, both the top and bottom, so that I can get a common denominator of x minus 4, x plus 4. So here I have colors here. 32 over top of x minus 4 plus 4x minus 16, that should be my 4, over top of x plus 4. X minus 4. Great, my denominators are the same. I can go ahead and add the tops. So I'm going to do it all in one step. I'm going to look at my numerators and say, do I have any like terms? Yes, 4x is all by itself, but 32 minus 16, that is a like term. So I'm going to go 32 minus 16, which is 16 on the top. And then I have x minus 4 times x plus 4 on Okay, so I think we're getting close to being finished. However, this is one of those cases where I need to keep going a little bit further. I see that my numerator can be factored. So I'm going to factor out a 4 and be left with x plus 4. X plus 4. And I factor out that, which is kind of cool because I can actually go a little bit further and simplify because I have an x plus 4 on the top and x plus 4 on the bottom. My final answer is going to be 4 over top of x minus 4. Cool. Okay, state my non-permissible values. X cannot equal positive or negative 4. Go back to your fully factored version for that. All right, your turn. Pause the video and try your turn. Here is the answer to the first two your turns. And here are the answers for the last two problems. Okay, that is the end of the lesson, so please do the practice.